G'day. James, tell us what was your inspiration to design the hardware? What inspired you to do this?
Right. Inspiration is a very strong word, but I think in the context of the cybernets theme, I've tried to think about something that was like, I don't know, very summer nats, but also very tech. And, you know, the idea of a Nokia 3310 swinging from a lanyard, it sort of struck the right vibe. And I mean, from a hardware perspective, I think my MO is always to get people thinking about hardware and actually thinking about the constraints of hardware, because it's everywhere, right? So with the choice of components and things like that, I was looking to make something quite minimal and also something quite constrained, so people had to think about memory and had to think about like a lot of the techniques that people used to use when they were designing embedded systems, gaming consoles. It was all actually very clever hacks and tricks to actually get like functional user experiences out of devices like that. And I think that's the experience we've delivered.
And we'll talk to Pete in a sec about the hacks that he did for the software. Yeah. But you've made you've chosen the components so that you can use development environments that people are familiar with.
Yeah. So it's based around an Atmega 328P, which is the CPU that's used in the Arduino Uno. It's fairly custom hardware, but you know, it's programmable using the Arduino IDE.
And you've said you've overclocked the...
It's running at 16 megahertz, where 8 megahertz is typical for an Arduino.
Nice.
And we've got that working at 3.3 volts, which is out of spec. Like, that's not ordained by Atmel, so it works fine. It's it's going to be fun to see what people do with it, because there's a lot of libraries, a lot of code out there for the Atmega 328P, and we've got some good peripherals we've got to it.
That's You've done a great work with the header to add accessories and things like that as well.
So tell us about can it interface with other things, or what are the headers that you'd expose?
Yeah, so based around the DEF CON SAO port, or shitty add-on, we've got the less shitty add-on port, which adds SPI, the reset signal, so it can also be used to program the microcontroller. It's also got serial TX and RX. So essentially you've got most of the useful functionality of the board broken out onto the LSAO header. It also provides 3.3 volt power, so it's actually able to completely power an add-on to the board. Anything using SPI, I2C, serial, it can interface with the microcontroller.
And obviously the hardware hacking village will be there to kind of help other people if they want to build their own accessories. We've got a couple of our own that are in the works at the moment.
That's awesome. And now for the software side of things, I mean, you've got such a constrained device and you want to put so much on there. Tell us a little bit about some of the challenges that you face with getting your code onto this device.
Well, I think it started off with me actually giving you a bit of a hard time at my talk last year, complaining about the screen size and color resolution of the previous badge. And instead, you gave me a monochrome badge to kind of say, see what you can do. It's probably the most constrained software environment I've ever worked in. A lot of the initial prototype work I did in C++, but that uses a lot of memory, so I moved a lot of it back, redid it into C. Things like there are images that get displayed in the badge, and I was running out of bytes. I think the final firmware has like 4 bytes left in the program space, which is incredible. And literally taking images of Parliament House and cutting off the flag, putting it as a separate image, and then drawing it back on so I can save the bytes on the sides. There's a whole bunch of other things like, Snake, which is also on the badge because you can't have a Nokia without Snake. And there isn't enough RAM, there's like 2 kilobytes of RAM, so you can't store the coordinates of every segment of the snake. So instead I store the first coordinate, and then I have 2 bits that represent whether the next segment is up or down, and then it kind of draws it back. And then every application on the device reuses that same 2 kilobytes of RAM and reuses it. And I have no doubt that there's a whole bunch of bugs and stuff in the software that I wrote for it. But it was pretty fun, and I think it's very much echoes vision of the working within constraints. It's actually a really fun way to program. I found it quite challenging, and I hate to think of how many hours I put into it. I think things like I was looking for ways to store strings and images, so I created a file system layer as well, and there's amazing things you can do even with only 32 kilobytes of program space.
So, but just to sort of, I suppose, to finish off, give us a high-level overview of some of the functionality that the people using the badge or looking at the badge will see.
So it has a really good feel with the opening menu where you've got the power and battery bar on the side. I think that'll hit a big nostalgia button. It has a dialer, so all those old school Nokia codes, get out your manuals and have a bit of a play around. I think there's some interesting ones. And there's also some undocumented ones for those to find. It has Snake and Tetris, and with the games, it actually, when you get a game over, you'll get a QR code to kind of like scan and upload those codes. So for the first time ever, you can actually compete against everyone else at the conference for scores and points in the games. But the tokens themselves, given that it's just an Arduino, it doesn't have any like security chips and features, I'm expecting that towards the end of the second day there might be some interesting scores that start to appear on the scoreboard. But I think as long as it lasts the first day, I'll consider that an achievement.
I think that's great. You guys did an awesome job and can't wait for the conference.
No, thank you, Silvio.